Hola, ¿qué tal? How you doing, Algebra 2A students? Today we're going to multiply polynomials. The concept's easy, but it's something that you're going to just have to be careful with, all right? And I'm going to show you some different ways to do things, and you can decide what you like best. So if I'm going to multiply, the simplest problem is just a distribute problem. When I multiply a monomial times a binomial, trinomial, four-term polynomial, etc. Y'all know how to do this. So on the first one, 3 times 7 is 21. X cubed times x to the fourth is x to the seventh, because when you're multiplying like bases, you just add exponents. You all know that. 3 times negative 2 is negative 6. X cubed x squared is x to the fifth. And 3 times negative 9 is negative 27. X to the third is it, and we're done. Okay, so on the next hardest problem, you multiply a binomial times a binomial. And your method 1 for this is FOIL method. So that's when you multiply the 3x squared or the 3x cubed times first and second. So when you say 3x cubed times first, you get 21x to the fifth. When you do 3x cubed times second, you're going to get negative 6x cubed. So that corresponds to first outer, okay? So then the IL part corresponds to you doing 2x times first, 2x times second. So 2x times first here is plus 14 x cubed. That corresponds to inner. 2x times second is minus 4x, and that corresponds to last. So I'm saying it a little differently because of where we're headed with this. Now, you know that you say, okay, 21x to the fifth stands alone. Negative 6x cubed plus 14x cubed can be combined to 8x cubed. And then you've got minus 4x, which will stand alone. We're done. We've added our polynomials, and we've got it in descending order. All right. So method 2 is a more visual thing. I don't think you'll use it for FOIL, but let me show you anyway, and it's the box method. So I'm going to say, let me put 3x cubed and plus 2x, which is my first binomial along the top. You're going to have an empty corner here, so this is always empty. So we love this problem. Don't put anything where the heart goes. All right, you'll have 7x squared. This is your second binomial, and minus 2 down the left-hand side. Now what you're going to do is say, if I multiply 7x squared times 3x cubed, I get 21x to the fifth. Then if I multiply 7x squared times 2x, I'm going to get plus 14x cubed. So you're letting your fingers trace. The box will tell you what to use on the left and what to use on the right. So for instance, guys, in this box, I need the negative 2 on the left and the 3x cubed on the right. And when you multiply those, you get negative 6x cubed. Last but not least, in the final box right here, I need negative 2 on the left, positive 2x on the top, and when I multiply those, I get negative 4x. Now what you're going to do is use diagonals. So your final answer is going to come from you combining the colored stuff. So if I go up this diagonal, 21x to the fifth is the only thing I can put together. On the next diagonal, I've got negative 6x cubed and positive 14x cubed, which is positive 8x cubed. And then on the third diagonal, I've got minus 4x. Okay, and that'll help you combine like terms. So like terms will be on a common diagonal. So the box method is good, especially when we get into the bigger problems, and I wouldn't necessarily use it on a regular basis, but it might be good to get you going so you see process, and then you'll probably refine to one of the other methods that's not box method. So how do you multiply a two-term binomial times a three-term trinomial? Well, the first method is to just, I'm going to write the problem again so I can show arrows and stuff. So what you're going to do is you're simply going to have to say, let me do first times first, first times second, first times third. When you do that, first times first is 21x cubed. First times second is negative 6x squared. First times third is plus 9x. Now I'm going to do second times first, second times second, second times third. So second times first is minus 14x squared. Second times second is plus 4x. Second times third is minus 6. Now you've got to come back and say, let me put together like terms. So I see a 21x cubed, but nothing that goes with it. I see a minus 6x squared and a minus 14x squared, so that's minus 20x squared. I see a plus 9x and a plus 4x, so that's plus 13x. And then last but not least, you've got your minus 6 on the end. Okay? Now, I've said that that's the horizontal method. Now, the next method, which is the column method, is almost identical. Okay? The one thing about the column method that's nice, well, there's two things. Number one, you can keep the problem from stringing out all the way across your paper. Because imagine if you have two terms times three terms, you got 1, 2, 3, 4, 5, 6. Well, if it was three terms times three terms, you would string it out and have 9 terms. If it was 4 terms times 3 terms, you would string it out and have 12 terms, and that starts to get really wide on your paper. So the next method saves a little space, but you can also make your addition at the end faster. So we're going to do the same thing, but just arrange our terms a little different. So first times first, 21x squared, this part, or 21x cubed, this part's not changing. First times second, negative 6x squared. First times third, plus 9x. Now, every time that you move to a new term in the first set of parentheses, you're going to make a new row of work. So now I'm moving to the 2 in the first set of parentheses. So second times first is negative 14x squared. And then when I make my new row, I'm going to line up like terms as I go. So second times second is plus 4x. Second times third is minus 6. Then when I wind up needing to combine like terms to finish it up, I just add columns. So all the terms on this column add up to 21x cubed. All the terms on this column add up to negative 20x squared. All the terms on the third column add up to 13x. And then all the terms on the fourth column add up to negative 6. So you're just adding down the columns. So I kind of like that method when the problems get bigger, 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 just because it lines up like terms and saves space. Now method 3 is the box method. So if you're going to do the box method, let me say that I've got 3x minus 2 on the top. It doesn't really matter which one of these that you put on the top. Remember, you don't have to put the heart here, but we love box method perhaps, but don't put anything in that top corner. It needs to stay blank. So your second polynomial is 7x squared, and then minus 2x, and then plus 3. So it doesn't really matter which polynomial you arrange on the top and which one you arrange down the left-hand side. Okay, so that's neither here nor there. Now guys, so in this box I need to use 7x squared and times 3x, which is 21x cubed. In this box I need the 7 and the negative 2. So that's negative 14x squared. In this box, I need negative 2x from the left, positive 3x from the right, or from the top. That's negative 6x squared. In this box, I use the negative 2x on the left and the negative 2 on the top. That's plus 4x. In this box, 3 is from the left, 3x is from the top. That's plus 9x. In this box, 3 from the left, negative 2 from the top. That's negative 6. So if I look along my diagonals, my first diagonal is here. That's 21x cubed. My second diagonal is here. Negative 6x squared, negative 14x squared is negative 20x squared. My third diagonal is here. So plus 9x and plus 4x is plus 13x. And then my last diagonal is here, and that's negative 6. So again, the diagonals help you group together like terms. I've gotten the same answer all 3 times. Take your pick. All right. So I generally, see if I can talk right, like the method of doing the separate rows and then adding along the columns. So I'm calling it the column method. You take your pick, okay? You might want to stop the video, try these on your own, and then watch me do the problem and see if you got it right. That would be a good way to do it, and write it up however you want to. So I'm going to do the column method. So first times first is 8x to the fourth. First times second is negative 4x cubed. First times third is plus 12x squared. First times fourth is plus 20x. Now I'm going to start a new row because I'm moving to the next term in the first set of parentheses. So second times first is plus 2x cubed. And I'm putting my x cubes in the same column to make it easier at the end. Second times second is negative 1x squared. Second times third is plus 3x. Second times fourth is plus 5. I am now ready to combine my like terms. So first column is 8x to the fourth. Second column is negative 2x to the third. Third column is plus 11x squared. Fourth column is plus 23x. And then last column's plus 5. So again, that's my method of preference. If you like one of the other methods, that's fine. Pick the one that you feel the best at today, okay? The hardest thing about this is just staying organized and being super careful not to mismultiply or misadd. Most people are going to get process, so just be super careful. All right, so again, you might want to try this next problem. Stop the video, try it on your own, then start the video, and you can see if you did it right. And if you did it right, that's awesome. You know what's going on. So here I go. First times first, 4x to the fourth. First times second, 12x cubed. First times third, 20x squared. New row, new color. Second times first, negative 5x cubed. Second times second, negative 15x squared. Second times third, negative 25x. New row, new color. Third times first, plus x squared. Third times second, plus 3x. Third times third, plus 5. Wrap it up. 4x to the fourth, plus 7x to the third. Let's see, 20 minus 15 is 5, plus 1 is 6x squared, minus 22x, plus 5. Again, if any of this is not making sense, make sure you can that you know you can always jump on Zoom with me. So we're going to finish up the last group of problems, and these are ones where you have to go two steps, all right? So for instance, what I've got to do first is multiply these. So I'm going to put that product in brackets and just put the 2x plus 4 there on the end. So I'm going to clean up in the brackets, and then I'm going to have to multiply again. So to multiply the first two binomials, you know you do first, outer, inner, last. And some of you may have gone, wait a minute, a plus b, a minus b, that's a squared minus b squared. And you might have realized that those will cancel. So now the first brackets will reduce down to x squared minus 81. So now that the first brackets are cleaned up, I usually replace them with parentheses. Now you got to go full again. So you're going to have to multiply, clean up, and then multiply, clean up. So you'll have this process twice in one problem. So first, outer, inner, last. So what is that? Negative 324. We better double check my arithmetic. I did that in my head, but let's just make sure that I'm not saying. Whoop, whoop. Yes, okay, I just wanted to make sure I hadn't done goofy arithmetic there. So I've got 2x cubed. Oh, there's nothing to do, guys. None of those are like terms. So forget that. I don't need to do anything. I'm done already. Not only do I have my terms condensed already, but they're in the right order. So, hey, I'm done. Cool. Now, on the next one, we're going to do the same thing. Remember, this part means 3x minus 1 times 3x minus 1. And then times the x plus 5. Okay? So I'm going to go ahead and do the first part. So I know that inside the brackets, I've got first, outer, inner, last. I'm going to clean up what's in the brackets and turn it into a parenthesis problem. You can leave it brackets. There's nothing that says you can't. So I see minus 6x I'm going to put together plus 1. So I want the brackets completely cleaned up. Okay, now look, I've got a problem where I've got a 3-term trinomial times a 2-term binomial. 3 terms times 2 terms will give me 6 total terms. I'm going to go back to column method because that's the one that I feel like saves me the most space or whatever. So first times first, 9x cubed. First times second, 45x squared. New term, new color. Second times first, negative 6x squared. Second times second, negative 30x. New term, new color. Third times first. Third times second. Add them up, get an answer. So 9x cubed first column. 45 minus 6 is what? 39. X squared second column. Minus 29x third column plus 5. All right, last but not least, if I cube something, keep in mind that I should write this as 2x minus 1 times 2x minus 1 times 2x minus 1. Okay, and there's something else you'll see later that you can use to speed this up, but for right now, we're just going to keep it straightforward. So I'm going to go ahead and do the first two. So I'm going to take care of what's in the brackets there. So when I do that, I've got first, outer, inner, last. I'm going to remind you that what I just did was 2x minus 1 quantity squared, which you have a quick trick on, FYI. there's another way you could speed up that first step. So let me, on the bracket part, simply put the minus 4x together. And then I'm going to rewrite it with parentheses, and I'm ready to do the 3 term times the 2 term like I did in the previous problem. So I'm going to say first times first, first times second, switch colors, second times first, second times second, and last but not least, third times first, third times second. First column, add the second column, -4 or -8, or -4, -8 is -12. I've got an extra dot there that I don't need. +4 and +2 on third column, and I'm done. Okay? So again, these aren't that difficult. You've just got to be careful. That's the big thing. Now, I'm going to show you one more problem, but we're not probably going to work out all this. If you see a geometry application, don't get real crazy, okay? Keep it simple. You're all right. So I know from geometry that if I want the volume of a prism, that I just do length times width times height. So it doesn't really even matter if you put them in that order, okay? Just as long as you multiply the 3 dimensions by each other. But for this problem, I'm labeling the length as 3x plus 2. I'm labeling the width as x plus 3. And I'm labeling the height as 2x minus 1. So that would be one expression for the volume of the box. But if they want you to multiply it out and simplify, then we've got to do what we did on the problems before. So remember, I would say let me take the first 2 and do FOIL method. And then when I get the what's inside the brackets cleaned up, I would multiply my 3-term trinomial by my 2-term binomial using either the horizontal method, the column method, or the box method. And so this is not anything new. It's just you start and you look at the picture and you set up your own multiplication problem. But then it's the same as it has been. So that should take you to the point where you're able to do the MML for today. So fewer problems, but they take a little bit longer. Just be careful. Get on to Zoom if you have any questions whatsoever.